Okay, this is series calculation. You ready? These are series problems. Now, what we have to do is add the total resistance. Okay, number uno. 322 ohm resistors are connected in series across a 125 volt generator. What's the equivalent resistance of the circuit? What's the current in the circuit? Does the current change or does it stay the same in a series? Look at your little chart there. It stays the same. So, whose law are we going to? We're going to use Ohm's law. And Ohm's law is voltage equals amps times resistance. You use that same equation multiple times for all circuits, series or parallel. This is called Ohm's law. Well, what is an ohm? Well, it's these little headphone things. That's an ohm. Who invented that, Alejandro? Mr. Ohm. When you invent a unit, you discover something, you name it after yourself. You should call it a green.
I thought it was ohms.
Okay, how do we get an equivalent? Our equivalent is the same thing as saying R total. How do you do that in a series circuit? Just add them up. So you have 322 ohm resistors. So it's 22 plus 22 plus 22, or 3 times 22 ohms. The headphone thingies in to go, once again, are ohms. Okay? So it is what? 66 ohms. That is the total amount of resistance in the whole entire thing. Well, what's the current? Well, it's connected to a 125 volt generator. The current stays the same in the entire thing, so we can use 66 ohms. So it's just divide both sides by 66. And what are the units of current? Amps. And you know who discovered that? Mr. Ampere. And when you discover something, you can get it after it. So 125 divided by 66. 1.89. 1.89 amps. Okay? That is the current in the entire circuit. Oh, yes, sir. That's a great question. All righty. I think I saw this somewhere in the textbook. 0.1 milliamps. That's what you do in the video. Well, that's, you can barely feel that. I don't think you can even feel that. 15 milliamps. You're going to shock yourself with the Van de Graaff generator. Anything more than that, it will really, really, really hurt you and or shock you to the point where you lose muscle control. 100 milliamps. Death. Death. Like instant death. Fast electrocution death. Yep. Milliamps. So how many amps is that? 0.1. Now, if you have dry skin, maybe not. If you have wet skin, particularly if it's in salt water or the pool, instant death. Because it turns you into a conductor. Terrence. People survive lightning strikes because lightning doesn't like to go through you. It wants to go to the ground because it's easier. It's particularly dry on it. And not only that, but you don't get struck directly by lightning. You get struck by one of the tiny little streamers.
Wait, still is that?
The big boat does not want to go to you. It would rather go to the ground. It wants to go to the ground by whatever is the quickest and easiest means possible. So it's going to follow that arc of charged particles. It's going to ride it down to the ground. Really tough, to be honest with you. But if you're in the way of that, it's going to try to go around you. It may not be able to. But you usually get, people get hit by the little streamers. It's almost never that they get hit by the actual main bolt. The electrician? The electric chair? The electric chair, they use salt water to conduct it through the person. No, it's fast. No, the person is instantly dead. It's just that his body is still contracting. What? Oh, well, yeah, that was back when. That was back during the Edison days when everybody was afraid of alternating current. They used to like shock elephants and use was to scare people. Next,
To show big.
because Edison wanted to do a smear campaign against direct current or against alternating current. Okay. Number 3, guys. A string of lights has 10 identical bulbs with equal resistance in connecting series. 10 bulbs. When the string of lights is connected to a 117-volt outlet, the current through the bulbs is 0.06. What's the resistance? I think we need to draw a picture.
All you do is divide.
Right? Whatever, positive, negative. Okay, you got 1, 2, 3, 4, 5, 6, 7, 8, 9.
This looks like the Griswold's house over here.
Yeah, that's right. It's like the Griswold sound. So what do those little squiggly lines represent? Resistors. There's 10 of them. Okay, and each one, well, we don't know. But we know that it's a 117-volt outlet. And we know that the current I stays the what? Same in a series circuit. But since these are all identical,
Yes.
since these are all identical, yeah. I just said
Sorry, I didn't quite catch that.
shut up, Siri. Oh. There's 10 of these. They're all
Christian.
No, it's because I said series. It's creepy how I want your iPhone listen to you. Okay, if I do this, Ohm's law, can I solve for the R equivalent? Yes. Okay, divide V by I, so 117 volts divided by 0.06 amps equals our R equivalent, meaning the total. What's 117 divided by 0.06? 10,950? 1950, all right, so 1950 ohms. Ohms. That equals your RDQ. And then, since we have 10 of them, we're going to what it is on each one, divide by 10, and you have 195 ohms on each. Okay? Now we're going to skip directly to the challenge one. Yes, Christian Pagan, directly to the challenge. Write that down. If you didn't get it, it's on the YouTubes.
You got to end it with my pleasure.
No, we're not done yet. That's number 6. Calculate the potential difference across 3 resistors, and now they're all different. Okay? Plus, minus.
Just add them.
Okay? Yes, you add them, but it says verify that the sum of the potential differences equals the potential difference across the battery. So if the battery is 75 volts, are all these resistors going to be working with the same volts? They will not. They will all have the same what, since they're on the same wire? Current. On the same wire, so they all have the same current. But, like I said in the beginning, in class, you can have different resistors on here, right? And if you put a curling iron and a lamp and a television on a series circuit, what do you think the current curling iron will do the rest of it? It'll bog down the rest of it. Okay? So now those are R's. Okay? What stays the same throughout the entire circuit? The amps. Well, where are amps? How do we do amps? Okay, here's how you do it. Ohm's law again. The total amount of volts is equal to the current, which always stays the what? 7 times the R total. The R total. What is the total amount of volts? 75. Okay. Now, what's the total amount of R's?
30.
You got to add those up.
32.
32. Okay. 32 ohms. Again, the little headphones thing in to go is ohms. drawing those either. 75 divided by 32 gives you the current for each one of those. Okay, 2.34 amps. Now, guys, in a series circuit, do these amps change? They do not. They are all on the same wire, therefore all of them have the same current. Period. They're all on the same wire. All of them have 2.34 amps of current running through them. Okay? But are the volts going to be the same? They are not. So what you do is, now that you have your ohms, you go V equals 2.34 times each one of these ohms. And you'll be able to find the volts at each one of these. I know what you're thinking. You're thinking, what are volts and what are amps? Okay, amps is current. That means the electrons are moving. It's basically a measure of how much the electrons are moving. Volts is potential energy. It's how strong the electrical field is right at that point. Do your lights dim when you turn on your hair dryer? Now it is still possible. It is still possible, guys, in a parallel circuit that you can dim the lights because you are drawing. Oops. You are still drawing a bunch of current. I think it's a little bit more complex than what meets the eye, but it could still happen. You dim the lights a little bit with parallel circuit.
Why'd you move this early?
All righty, here we go. Multiply, please. What's the answer to the first one? 28.08 volts. Okay. What's this one, Grady? All right. 35.1 volts.
11.7.
11.7 volts. Do all of these add up to 75? 28.05 plus 35.1 plus 11.7.
Yeah.
All right, that all adds up to 74.8
And
volts.
resistance of the wire. 0.2.
Okay.
The length of it.
All right, guys, what you just did is what they do at Votech. Yes, they do too.
Well, they do more than that.
They do too. They do these guys. As a matter of fact, they have a chart that they look at with the equation. That was series circuits, DHS physics.
My
Like,
pleasure.
comment, subscribe, smash the bell.
No, my pleasure. Chick-fil-A. My pleasure. Chick-fil-A headset.
No, no, because it's in my feet.
Guys, everybody sit your stuff.